Hello again, this is Robert Veach here. This is my video review of the WZRELB brand. They're a 300 watt pure sine wave power inverter. It'll handle 600 watt peaks. It takes DC and 12 volts and produces about 120 volts AC. Great for off-grid work. It has an LED display in there. We're going to power this up, connect it to a 12 volt battery. This product gets excellent customer ratings. We're going to measure the sine wave output on here. We're going to load it down and take a look at everything on here. These are great. I love the size of this and the form factor. It's not too big. It's only about 2.2 pounds. It's 8.5 by 4.6 by 2.9 inches. And what's great about the output being a sine wave is that it's going to produce an accurate enough wave to use for a CPAP machine, as an example, or a PC. I'm going to use this for my CPAP backup, lose power often, and I'm going to be able to run my CPAP device with this. There is the front. You can see right there, it's got the on-off power switch, a LED red display, and there's your power output right there. It has nice terminals, openings right here so that you can mount it, and there are specs and contact information right from the company right there so that you never lose it. And on the input side, you can see it has a miniature fan that, according to the manual, is temperature controlled. It'll come on if it's needed, and we'll test that out. And you see it has the terminals right here included, the red and the plus, and you have the washers and the compression washer on there, and the 12 volt DC input connections, and that's the appropriate gauge, so that because 300 watts in the current that's going to be drawing, that is appropriate for this. As you go higher and higher in wattages for any inverter, the cable gets thicker and thicker because the current going in rises to compensate to give you that output power at 120 volts. That's just how they all operate. It also has a nicely written manual showing you the waves it produces and also letting you know about the screen display and what everything means, and recommendation size for battery cables and fuses based on the wattage of the unit. But this, they already picked it out for you. This 300 watt, 600 watt peak is already selected for you. So let's give this thing a try. Let's hook it up and let's go from there. And here I have the plus to the plus and the minus to the minus. So here I'm connected to a 12 volt. This is a lead time lithium phosphate polymer battery plus 12 volt 50 amp hours. The connections that came with this inverter work perfect for it, so this is a perfect application to test this out. And when you first turn it on, the fan will come on for a short time. As it tests itself, you listen, you hear the fan, and then what it'll do, it'll sense that there is no thermal load, and then the fan should shut off. And it shows you the voltage, 13.8 volts. It's a blue LED. I like that. It looks really high tech. So now we're going to take some measurements on this device. And one of the first tests, I've got a multimeter right here, and I have it across the terminals, and you see it's 120.9, 121 volts. That's telling me that's producing AC from that input of 13.2 volts DC. So it's doing what it's supposed to do as an inverter. And here's an important test. I've got the output going to an oscilloscope, and you can see the beautiful sine wave on there. And that's important. That shows you that it really is a sine wave. It's not a step wave or a square wave or a triangle. It's a beautiful sine wave. So anything that's sensitive to the frequency or the quality of the signal, this is going to work just fine. That's exactly the frequency you want, and that's the perfect sine wave you want. So I'm impressed with that. Here's just a simple test. I have a pretty high wattage LED garage light, and I have it plugged right in right there, and it's powering the light perfectly. And I still have a nice strong voltage there. The power supply side here hasn't kicked on the fans because it's only about 100 watts, which is great, and showing me that it's running it perfectly, very bright. Here's another device that I have that it's a tester, socket tester, and showing me that it's got 120 volts on there, and it's just blinking on the ground because I don't have it obviously grounded, but showing me that it is a correct hot and neutral and 120 volts. Here I have a watt meter hooked up to it, and I have a load on it, which is a heat gun, which is pretty high wattage. It can go up to 1500 watts. We're going to try and control the wattage on. I'm going to turn this on, and now the heat gun is running. About 169 watts on there, 173 watts right there. I can feel the heat spewing out of here. So it's running that perfect. Now I can increase this a little bit, but you don't want to increase it to the point where the safety circuitry will come on, but it will protect it if you overload the unit. So right there's 206 watts, and you see it's still working fine. My input voltage is 12.4 volts. So as long as you are conservative about how much power, there's 200 watts right there, this is going to work beautifully, and it's going to produce that 60 hertz, 120 volt, pure sine wave output. In this case, I'm giving it a resistive load with a motor, and it's working just fine at 200 watts plus. After testing, what do I think about the WZRELB brand, or 300 watt pure sine wave inverter? I love this product. As I demonstrated, it's a beautiful pure sine wave. This thing drove the loads perfectly with a clean signal. So I'm going to give this product a full 5-star rating. I hope this video review helped you with your buying decision. Thank you for watching.